Okay, we are going to look at example 3. It is an entertainment application. What it states is that a roller coaster starts by ascending, that means going up 20 feet for every 30 feet it moves forward. The coaster starts at a point 10 feet above the ground. Write the equation of the line that the roller coaster travels along in point slope form. Okay, so we're going to have to write an equation in point slope form and use it to determine the height of the coaster after traveling 150 feet forward. Assume that the roller coaster travels in a straight line for the first 150 feet. So what we're going to have to do is write an equation in point slope form, which is y minus y1 equals m multiplied by the quantity x minus x1. Okay, now for this formula, we need to know two things. We need to know what the slope is, and we need to know a point. x1, y1. Okay. Now, let's reread this and look for that key information. So it says a roller coaster starts by ascending 20 feet for every 30 feet it moves forward. That is actually going to be the slope. 20 feet for every 30 feet it moves forward. So it goes up 20 over 30, up 20, up 20 over 30, up 20 over 30. To me, that sure does sound like a slope. So our slope is going to be equal to 20 over 30. Now, we could totally reduce this, which we will for our equation. 10 goes into 20 2 times, and 10 goes into 30 3 times. So our actual slope is 2 over 3, okay? That is what we're going to insert into our formula. But for graphing purposes, I'm actually going to keep this one handy because I'm going to use this form for my graph. Okay, the next thing that we need to do is locate the point. So it gave us the slope right there. Now we have to find, well, where's our point? And it says the coaster starts at a point 15 feet above the ground. So it gives us the word point there, which is nice. Or did I say 15? I meant 18 feet. I'm sorry. 18 feet above the ground. All right, that is our point. So if it starts at 18 feet above the ground, okay, it has a vertical distance of 18, but its horizontal distance is actually 0. So what we are going to say for our point is that our horizontal distance, which is x, that is 0, but our vertical distance is 18. So that is the point that they give us, 0, 18. Now we're just going to insert these values into our equation. So we get y minus y1 is 18 equals our slope, which is 2/3, all over x minus x1, which is 0. And there you go. There you have it. There is our equation. Now from here, we can go ahead and graph that information in our graph, okay? We always graph the point first, which is 0, 18, which would approximately be here. Well, we know 0, 18 would probably be about here. Now from this, I have my scale in 10, so 10, 20, 30, 40, 50, and so on. So I'm actually going to use this format of 20 over 30 because it's going to be way easier. So I'm going to go up, this is going to be up 10, up 20, and then over 30, 10, 20, 30. So that point's going to be about there, and then I'm going to do the same thing. Go up 20, 10, 20, over 30, 10, 20, 30, about there. Same thing. Go up 10, 20, over 30, 10, 20, 30. Same thing, up 10, 20, over 30, 10, 20, 30. And go up 10, 20, 10, 20, over 30, 10, 20, 30. Okay. We're going to have one more time. I'm going to go up 10, 20 over 30, 10, 20, 30. Right about there. Okay. Now if I go ahead and connect all these points, I would have something like this. Okay, now what does the problem ask us? That's a graph of our line. The problem asks us, okay, it says write an equation of the line that that the roller coaster travels along in point slope form, which is what we did, and use it to determine the height of the coaster after traveling for 150 miles forward. So 150 miles forward, that would be the x. So basically with our equation here, oh, this x minus 0, we can simplify that. I should have simplified that. X minus 18 equals 2/3 just x, because x minus 0 is really nothing, so you can write it that. So this is actually what our equation would be. So what we're going to do is we're going to use our equation, and we want to know the horizontal distance. We want to know the horizontal distance of, you know, how high is it when it is 150 feet forward. So really we want to know, well, what is it when x equals 150? Okay, so we're going to plug this value into this equation. So I'm going to write y minus 18 equals 2/3, and I'm going to substitute 150 in for x times 150. And here I just have a little fraction work. How many times, so is there a common factor between 3 and 150? Yes. 3 goes into 3 one time, 3 goes into 150 50 times. And then I just, you know, multiply across. I get y minus 18 equals 2 times 50, which is 100. And then I'm solving for y. And what I have is y equals 118 feet. What that means is that when x is 150 feet, I actually just found a point. When x is 150, we know that y is 118. Okay, so this point should be on the graph. Let's go ahead and check and see if it is. So this is our x and this is our y. Let's go over to the horizontal distance, which is 150. So what this is stating, we used our algebra skills to figure out that when it's 115 feet, it should be 118 feet vertically. So let's go up to what this point is. Well, this is 100 here, and this is 110, and this is really close to 120. So yeah, I would say that that is about 118. So we know that what we did was correct. So there you go. That is our answer. The height would be 118 feet. Okay, now it is your turn to do a similar problem. So go ahead, pause your, oh, where's our friend? Where is he? Where's our friend? Here he is, the pause dragon, reminding you to pause and then work this out and come and see if you did it right. Okay, good luck. Bye. All right, let's go ahead and read this problem. It states a roller coaster starts by ascending 15 feet for every 45 feet it moves forward. The coaster starts at a point 15 feet above the ground. Write an equation of the line that the roller coaster travels along in point slope form, and use it to determine the height of the roller coaster after traveling 300 feet forward. Assume that the roller coaster travels in a straight line for the first 300 feet. Perfect. So we have to put something in point slope form, so I'm going to go ahead and write that down. Y minus y1 equals m multiplied by the quantity x minus x1. And yes, I want you writing this down every single time. Okay, for this form, we need a point. We need an x1 and a y1, and we need a slope. We don't know what those are. So let's go ahead and read and find this information. It says a roller coaster starts by ascending, going up 15 feet, and then moving 45 feet forward. Up 15, 45 feet forward. To me, that sounds like a slope. So we're going to go up 15 over 45. So our slope is actually going to equal up 15 over 45. That is the rise and the run, up 15 over 45. Now, we could reduce this because 15 goes into both of these. 15 goes into 15 one time, 15 goes into 40, 15 goes into 15 one time, and 15 goes into 45 3 times. But I'm actually going to use this version of it when I graph. So, but for my equation, I'm going to put in 1/3. So that is my slope, and then my point is, okay, the roller coaster starts at a point. of 15 feet. So it tells us the point. It starts at 15 feet. So the horizontal distance is 0. It starts, so it hasn't went anywhere horizontally, but it starts at 15 feet. So that is our vertical distance. Okay, so we're just going to go ahead and plug in this data here. So my y minus my y1 is 15 equals my slope, which is 1/3, all over x minus my x1 is 0. I can go ahead and simplify this to y minus 15 equals 1/3. X minus 0 is just x. And there you have it. There's my equation in point slope form. All right, from this, I'm going to go ahead and graph my line. Okay. Whenever you're graphing from point slope form, you start at the point, which is 0, 15. Which I have my horizontal distance and my vertical distance here. My point is 0, 15. And my slope is equal to 1/3, but I'm actually going to use 15 over 45 because it means the same thing, but I have my, I had to label it in increments of 15. So my starting point is 0, 15. So here's 0, up 15 is right here. Okay. From here, I'm going to have my slope, which is up 15 and over 45. So from here, up 15 over 45. 15, 30, 45 there. And then again, up 15 over 45. 15, 30, 45. 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 Up 15 over 45, 15, 30, 45. Up 15 over 45, 15, 30, imaginary 45 right there. Okay, so now I'm just going to go ahead and connect those dots. And there you go. Okay, perfect. Okay, so what the problem says, it says, write the equation of the line that the roller coaster travels along in point slope form. We did that and use it to determine the height of the roller coaster after traveling 300 feet forward. So 300 feet forward, that is talking about the horizontal distance, which is the x. So I'm going to say we need to figure this out when x equals 300. So we're just going to go ahead and input that value here. Y minus 15 equals 1/3, and x is equal to 300. We substitute that in, and we have a little fraction work here. We look to cross cancel always, and there's a common factor of 3. 3 goes into 3 one time. 3 goes into 300 100 times. All of this just ends up being 100. Minus 15 equals 100. And then we add 15 to both sides, and we get y equals 115 vertical feet, okay? So when they have went 300 feet horizontally, the vertical distance is 115 feet, which is our answer. And this makes a lovely point. The point is 300 for the x part and 115 for the y part. Now let's go to our graph and see if this makes sense. So here we go. We need 115 feet. So this right here is 300. All the way, let's see, counting in up to here, this is, where is this? This is 90. This would be 90 plus 15 would be 105. And this is 120. So yeah, that does look like it's about 115. Now on this, it's, you know, hard to tell because it kind of is in between those points. But I would say yes, that is about 115. So it looks right. All right, if you got that right, yoka denki mashita, you did a great job. We will see you next time. Goodbye.